Hello, today we're going to have a look at differentiating exponential and logarithmic functions with other bases other than e. So here we're going to firstly prove this fundamental result of when we derive an exponential a to the power of x, we'll actually get a to the power of x multiplied by log to the base e, and then whatever the actual base was. So let's prove this. So the very first thing here, what I'm going to do is I'm going to let y equal to a to the x. Therefore, I can rearrange this so I can have the power at the front. X will equal to log to the base a y. Now I'm going to use the change of base because I want this as with respect to x. So I want y equals something, and then I'm able to derive that. So here I'm going to change a base. Okay, so I'll have x would equal to, and I'm going to use the base e, log to the base e, y over to log to the base e, a. Here I'm going to multiply both sides by the denominator here. So I'll get x ln a is equal to ln y. Now what I'm going to do is I'm actually going to take an e to the both sides. So I'll actually get e to the x ln a equaling to e to the ln y. And I'll do this to actually, so I can isolate y, because on the right hand side here, I'll get y. And on the left hand side, I'll actually just keep the remainder x, e to the x ln a. So if I'm actually going to derive this now, okay, and we can derive exponentials when we have a base e, we know what to do there. So if I had, say, just rewrite that, y is equal to e to the, let's say, ln a multiplied by x. So ln a here is the coefficient. So when I derive this, dy dx, the coefficient comes down the front, ln a multiplied by e to the ln a multiplied by x. Now, here what I have in the power, so when I have e to, say, I could just rearrange it as x multiplied by ln a, the power, or the coefficient here, or x can, the coefficient of the log can actually go up as a power in the log. So here, that would actually simplify to e to the ln a to the x. And you might see what I'm doing here. So the ln and the e will cancel, leaving this part here to just be a to the x. So therefore, dy dx is equal to a to the x multiplied by ln a. And that is what we were looking for. Okay, so let's have a look at question B. So B, we've got a numerical expression of y equals 5 to the x. So let's apply what we've learned there and see how we go. So very first thing to do would be to rearrange this. So I get x as the subject. So here I'll go x is equal to log to the base 5 y. Okay, I'm going to use the change of base. So we're going to use the same structure that we did previously. So here, change of base, so I'll go x is equal to log to the base e y, and I'm going to use e because that's what we do with our calculus in deriving. So here I'm going to have log to the base e and then 5. All right, awesome. So I'm going to do the same thing that I did before. Let's take this over here. Okay, multiply both sides by that denominator, so I'll have ln 5 multiplied by x is equal to ln y. Take the e of both sides, so I'll get e ln 5 times x is equal to e to the ln y. The log and the e will cancel. Okay, so I'm going to keep the left-hand side the same here. So here I'll have e to the ln 5, which will be the coefficient of x in this example, is equal to y. Now I can derive this, so I'll have dy dx will equal to, now the coefficient of x in the power here is ln 5 multiplied by, and then I'm going to keep the same, so ln 5 times x. Now I can rearrange this part here, so I'll have ln 5 multiplied by e to the ln 5 to the power of x. Okay, e and the ln there will cancel. So here I'll get an answer. Dy dx is equal to ln 5 multiplied by 5 to the x. Brilliant.